In this episode, we witness the rise and fall of Ordovician life, where trilobites, corals, and jawless fish thrived before a mass extinction. The Silurians saw jawed fish evolve, reefs recover, and plants like Cooksonia develop key adaptations for survival on land. The first land plants, evolving from algae, adapted by developing cuticles to reduce water loss and spores for reproduction. Vascular tissues helped them spread, shaping Earth's first ecosystems. Let's dive into the details of this groundbreaking transformation. A diverse group of ostracoderms swims near a coral reef. Some have streamlined bodies, navigating quickly, while others show spiny projections. Bony armor glistens as they filter feed. The environment is teeming with early marine life, highlighting their adaptability. Ostracoderms glide through a shallow Ordovician bay, feeding on plankton. Sunlight shimmers on their bony armor. Below, trilobites crawl along the sandy seafloor, while swaying marine plants create a rich habitat, supporting a diverse array of prehistoric marine species. Spiny ostracoderms drift through a shadowy Ordovician sea, dodging jagged rocks. Their armored bodies provide defense in these deep waters. Algae carpets the rocky seabed, while dim light struggles to penetrate, creating a quiet yet treacherous underwater world. A Silurian underwater landscape teems with life. Diverse marine plants sway gently in the current. Jawless fish glide by, while placoderms patrol aggressively, their armored bodies glinting. The water is clear, revealing rocky outcrops and coral-like structures beneath. A placoderm lunges, its powerful jaws snapping around a smaller fish. Water churns as the swift predator claims its prey. With armored plating and crushing bites, these ancient fish ruled Silurian seas, their hunting skills shaping the evolving marine food chain. Jawed fish swim in unison through the peaceful Silurian waters, their diverse forms glinting in the light. Beneath them, corals and sponges cover the seabed, supporting a vibrant marine world. These early gnathostomes mark a turning point in vertebrate evolution. In a humid, prehistoric world, early bryophytes cover damp rocks near a clear stream. Without true roots, they absorb moisture from their surroundings. The wet landscape supports their slow spread, shaping one of the first stable terrestrial ecosystems in Earth's history. A dense cluster of primitive bryophytes grows on a muddy bank, extending towards a nearby water source. The small, leafy structures are tightly packed, forming a carpet-like layer. The scene is overcast, with diffused light enhancing the rich textures of the foliage. A prehistoric field where early plants have developed structures to retain water, enabling survival in drier conditions. These adaptations are visible in their thicker, waxy surfaces. The sun is low, casting long shadows and creating a warm, golden glow over the scene. A vast, marshy landscape during the late Silurian period, dominated by small, early vascular plants like Cooksonia. These primitive plants stand upright with simple branching structures, absorbing sunlight. The air is moist and filled with the scent of wet earth. Cooksonia grows in clusters, its stems reaching skyward from damp ground. Spore-producing structures dot its branches. Sunlight filters through the primitive canopy, casting shifting shadows on the moist earth as these early vascular plants spread across the landscape. Cooksonia's spore-producing tips and textured stems stand out in sharp detail. Sunlight casts a glow on their green surfaces, contrasting with the soft, earthy background. These early vascular plants, primitive yet vital, marked a turning point in land plant evolution. Life flourished in the Ordovician seas, but cooling temperatures led to ice sheets and falling sea levels. Marine ecosystems collapsed, forcing trilobites and brachiopods to fight for survival. The changing climate set off a mass extinction, altering Earth's history. With sea levels falling, many shallow marine environments vanished, leaving exposed rock and sediment. The once bustling habitats became barren landscapes, with only a few resilient species managing to survive in small tidal pools, adapting to harsher conditions. As extinction reshaped ecosystems, resilient species adapted to new conditions. Small, hardy organisms found niches in the changing environment, paving the way for future evolution. These survivors laid the foundation for the emerging biodiversity of the Silurian period. A bustling coral reef shelters diverse marine life. Bright corals create intricate formations, home to fish and crustaceans. Jawed fish glide through the clear waters, showcasing their growing diversity as the reef flourishes, supporting a thriving prehistoric ecosystem. Large sea scorpions patrol the sandy seafloor, their elongated bodies and pincers making them apex predators. Smaller fish and invertebrates dart away as they move. In this shallow marine world, these powerful arthropods dominate, shaping the balance of the ecosystem. Primitive plants cover the rocky land, forming Earth's first terrestrial ecosystems. Leafy sprouts grow in clusters, while mosses and liverworts spread. Under a clear sky, sunlight nourishes this new vegetation, marking a major step in the evolution of life beyond water. Trilobites roam the sandy seabed, while graptolites float above in a thriving Ordovician sea. Coral reefs bustle with life, crinoids swaying with the currents. This diverse ecosystem supports a wide range of marine species, highlighting ancient ocean biodiversity. Early plants cling to moist Silurian soil along a rocky coast. Rhiniophytes with leafless stems stand among patches of moss. Waves roll against the shore, shaping a world where plants first established themselves, paving the way for future terrestrial ecosystems. Jawed fish fill a Silurian river, with armoured placoderms gliding through schools of smaller fish. Sunlight reflects off the rippling water, illuminating lush plants along the banks. This vibrant ecosystem provides shelter and nutrients, supporting diverse aquatic life. Thank you for watching. Creating high-quality content takes a lot of time and effort, from research to production. If you enjoyed this episode, please like the video and subscribe to support the channel. Your engagement helps us continue making great content. Stay curious and see you in the next episode.